Good morning everyone, and welcome to this Graitec UK Advanced Steel webinar, where today we're going to be looking at modelling the existing environment in Advanced Steel. My name's Rob Merriman. If you haven't met me before, I have 11 years of experience in the construction industry. Basically it's the only thing I've been involved with since I left university. I started off as an architectural metalwork and structural steelwork draftsman, both using advanced steel. I currently work for Graitec UK as an application engineer, so I provide training, technical support, implementation and customization for structural packages, mainly focusing on advanced steel, but with advanced steel being added to the AAC collection, we now look at all areas of the AAC collection for steelwork. A little bit about Graitec before we crack on with today's webinar. So we are a global company and we are technically driven. Out of the 550 staff we have globally, 350 are technical staff. 30 years old and operate through 11 countries worldwide. We are quickly becoming one of the largest Autodesk partners, and like I said, we've got 550 staff. 100 of those are located in our research and development center in Romania, producing our own software such as the Power Packs and Advanced Design, and we are here to help you guys and driven by you guys. So we work on thousands of projects worldwide. On our support, which is over 50,000 cases a year, we have a 98% excellent or good feedback, and across the world we deliver over 3,500 training courses. So why choose Graitec? We are the only company that can take your project from start to finish and cover all areas of the project, and we've broken those down into 4 areas. They are create, simulate, fabricate and manage. So create is using the Autodesk products and enhancing them with the Graitec Power Packs. Simulate is taking your BIM model and obviously making sure that it can work in real world with the loadings and things like that. So we have our own products such as Advanced Design and Advanced Design Connection to do the simulation. Fabricate is obviously then taking the model and getting it ready for fabrication. Obviously Advanced Steel fits in the create and fabricate category, but we do also have software such as Armour Plus and Advanced Workshop, which can look after and control your workshop for you. And then all 3 of those areas will create documentation and data, and that needs to be managed. So we have a product called Graitec OpenTree that can manage all of your data and then collaborate with any external common data environment. It's especially useful if you're working on 5 or 6 projects with 5 or 6 different common data environments. Graitec OpenTree will manage all of that for you. So a little bit about the content that Graitec produce. All our previous webinar recordings can now be found on our dedicated Advanced Steel portal. So this enables you to watch the webinars on demand. This webinar is being recorded. It will be available on the content portal roughly 10 days after the webinar is finished, so a couple of weeks time. Do you get our Advanced Steel blogs? If not, you can click on the link. There is a handout to this PDF with all of these links embedded in it. So you can click on the link and you can actually subscribe to the Advanced Steel blog, and then every time we write a new blog you'll get it straight to your inbox to avoid missing any new information. We recently completed the 2020 Digital Global BIM Up Conference. If you're a Graitec customer and you couldn't watch all the classes, or you couldn't see all the classes you wanted to at the time, all of the recordings will now go onto the Graitec Advantage site. So again, within the handout there is a link for the Advantage site, so you can log in and watch any of the BIM Up classes from 2019 or 2020 on demand. And finally, this is a UK webinar. I know we do have people from overseas, but this next statement relates to the UK customers. If you are a supported Graitec customer, you should be entitled to the Advanced Steel Power Pack. So if you don't have it installed or you don't have the license working properly, please let us know. Other countries, please speak to your local Graitec office about the power packs. So the upcoming webinars today, we're looking at modelling the existing environment. Got an important webinar on Monday, Alex looking at why won't my IFC files import. Then next Friday, Alex going to be running through what's new in Advanced Steel 2021 and some of the new functions. Then I'll be looking at resolving common issues with drawing views, and then finally we'll be looking at what's new for steel in Revit 2021. Again, all of our future webinars we will let you know over social media, and you'll get an email from Claire if you signed up to the marketing emails about you can control what content you see and you receive. If not, you can check up on our events page. So today we're going to look at what is the existing environment, how we go about correctly modelling that existing environment, creating the existing environment if it's concrete, creating cutouts in the slabs and the walls, looking at what we can do with GA drawings for the existing environment, and then we'll look at working with any supplied CAD drawings. So we'll start with what is the existing environment. So most of the time when we're using advanced steel, we will obviously be producing the steel members, but usually those steel members are bolting to slabs or walls or sitting within a building. So we want to model those items in the advanced steel environment, because if we model things in the advanced steel environment, we can clash check against them. It could be a new extension on a house, a new steelwork for an extension. Again, if we look at that picture, we've got windows, we've got brick openings, we've got brick recesses, we've got downpipes. Really, we want to be modelling that environment to make sure there's no issues with our steelwork when it gets to site. Or it could be some lintel steelwork in the house if we're removing a structural wall. So that we do need to model the walls to make sure that we've got enough bearing and things like that. What I used to do a lot of, we used to do when I was doing the architectural metalwork, we used to do lots of stairs and railings, so we would usually have cutouts in the concrete slab that our staircase had to come up and through. So again, we would model a slab and model a cutout. Or it just could be some plant work or an existing steel project that you're going back to do the second phase on. We still want to know where that first phase or the existing pipe work is, and that will help us to pick up any issues in the modelling stage, which is obviously a lot more cost effective and time effective rather than trying to resolve them on site. So we're actually just going to go straight into advanced steel, and then we'll work through all of these different bits and pieces. So we're going to just start a new template file. We'll put the project information in and save it. So we'll call this existing environment. And we'll say that Alec is doing the checking on this one. So we'll just save that in the existing environment. Okay, so I'm also going to give you some tips and tricks and show you a few pieces with the Project Explorer. We're going to create some levels. So we're going to do 0, which is going to be ground. We'll do 1, which is going to be first. And then we'll do 2, which is going to be second. So that gives me my models, my levels in the model. And then what we're going to do, we're going to put some columns in. We're going to do some existing steel. So I want my columns to go from ground to second, which is 6 meters. Now if I use the standard column tool, that uses a management default, and the management default for all columns out of the box is 3 meters, but what I can do, because I now have these levels, I can go to the work planes tab. We can just clear these values. So I can say I want the base of the column to start at ground floor, and I want it to run up to the second floor. Then if I use the column tool, we'll put a column in at 0, 0, 0, and we'll put a column in at 10 meters. Those columns are now 6 meters long, because they are, although the default is 3 meters, if you have work plane set, that will override the defaults. So we'll just set these to a 203. Now what I'm going to do to make them existing, because these are going to be existing columns, is in the naming tab, I'm going to change the model role to existing. That means that when we come to, if you want to and do some drawing customization, the drawing customization uses the model roles. So if you don't have the correct model role set, you won't get the output that you need on your drawing customization. What I'm also going to do is I'm going to go to the behavior and say, for single parts, I don't want to use for numbering and I don't want to use the bill of materials, because we don't want these two columns to show on our lists or drawings. Now you'll notice that I can't tick anything for the assembly. That's because we haven't defined these as the main part. Now this would normally get done when you do the numbering. The system would define the main part, and the main part is defined as the heaviest object within the assembly. There's nothing in this assembly at the moment, and I'm doing it manually, so I can say define as main part from the naming tab. You'll see that then gives me the assembly number and prefix options. And if I go back to behavior, I can say don't use for numbering and don't use for bill of materials. But importantly, I want to use for collision check. And then as the final step, I'm going to just change the layer. We have a layer in here for existing steel. So when you're modeling, it just makes it stand out for you. Now we're going to model a first floor beam. So what I can do, we can just clear these work planes. I'm going to activate the first floor level. So if we double click on it, we'll see that the first floor is bold. So now I can draw my beam, and it doesn't matter where my UCS is, because I've set the first floor level to active. So that means that anything I model now will be on this level. So we'll just set this up. We'll go top center. We want this to be a beam, and if we have a look, there's our beam. Now we can't see the top of the column. That's because the second level isn't visible. So if we turn that on, we can see that it's now visible, and we'll just deactivate the first floor level. We need to add a couple of basic connections in here. So the reason that we would model the existing steel is that when we add a connection, the bolts are the right length, because obviously we set the web thickness. What we're going to do in here, we're just going to call this connection 1. Now a new tool for 2020 was the propagate command. So if we select that, right click and choose propagate joint, it will look for a column of the same section size and model roll and a beam of the same section size and model roll, and it will put that joint on for me, and that has put them in a group, so that now if I updated this first one, this second one would change automatically. It does work quite well. You do have to be a little bit careful with it sometimes. If you've got, say example, we've got a shed and we have some purlins on there. At the end frame you would just use a single-sided purlin connection, but in the middle of the frame you would use a double connection. If you put the single on first and propagated, it would put two singles where you want the double. So what we need to do is actually isolate the double connections and turn those members off. Then we can propagate the single-sided connection, and then we can turn the middle bit on and then do the same for the double-sided end plate. So just it is a very good tool. You just have to be a little bit careful and make sure you clash check afterwards. So we will just clash check everything in here. So we found no collisions. So what we can now do is we can run the numbering. So I'm not doing anything different. I'm selecting everything in the model. You'll see that this item here is B1, which I want it to be. Now, the system still does need to number existing steel, but you can see that it gives it a minus 10,000 value. So that instantly tells me that those are not going to be used for bills of materials or anything, but the system still needs to differentiate. If you add 10 existing cot beams, it still needs to differentiate which are the same and which are different. So we'll just clear our marking in there. Now we need to run the drawings, so we will run all assemblies. So again, you're saying it's running everything, but when we have a look in the document manager in a second, you'll see that because we've set the steel up to be existing steel, it won't run any drawings for the existing steel. So you don't need to worry about selecting things or not selecting things or hiding things. If you set the existing steel up correctly, the system won't number, well, it won't give it a number that would be used in bills of materials or drawings. So you can see in here that we've only got the B1. And then what we would do is we'll run a material list. And you can see that we've only got the 254 10228, which is the beam spanning between the columns, and the two end plates. So the system will not do anything with those existing steels. So that's how I would do existing steel. Now we're going to look at modeling the concrete environment. So what we're going to do is we are going to go to the Objects tab, and in the Objects tab we have this Other Objects panel, and this is where we can model our concrete environment. So we have walls, polygon walls, concrete columns, rectangular slabs, polygon slabs, isolated footing, concrete beams, concrete curved beams, and continuous footing. So a lot of people do model concrete in different ways, or in the existing environment. Some people just use lines, some people use plates and then set them to be existing items and set the material to concrete. Some people use AutoCAD 3D Solid. I would try and use the concrete tools because we can then control things on drawings. We can control things on drawings with plates and things like that, but we've got to set up extra model roles and then model objects, and you've got to dig deep into the system to start adding and changing the presentation rules of these. So what I'm going to do is I'm just going to activate my ground floor, and we'll just see the first floor as well. So because the ground is bold within my levels, that is now activated, and we're just going to turn off the endpoint snaps. I'm just going to come in here. Oh, helps if you click the right button. We want to model a slab, so we'll just model a slab that is 12 meters by 10 meters. Probably a little bit big, but so that is my concrete slab to begin with. Then we want to model our concrete slab at the first floor, but I want to match what's on the ground floor. So again, I've turned the ground floor on, but the first floor is bold, so I'm now modeling at that first floor level. So we can just, I think what we'll actually do is just drag this in a little bit. We'll drag it in maybe 2 meters, maybe another meter. That looks a little bit better. And then what we'll do is we'll just model over the top of that, and because I've got my first floor active and bold, it puts it at that level. Now the front edge needs to be flush with our column, so what we can do, if I click that, I get the little grip like you would any AutoCAD rectangle or advanced steel plate, and we can just say align that with the end point in here. Because I'm not showing the top of the column, although it looks like I've got an end point here, that's just doing a slice through the model. So that's how I would go about modeling my concrete slabs. We'll just turn off, we'll just deactivate the levels. Now I want to model my concrete walls. So the concrete walls work very similar to the way the column works. So what I'm going to do is I'm going to activate my work plane. So I'm going to set the bottom of the work plane to the ground and the top to second. And then when I model my concrete wall, we're just going to trace around the outside here. That will now model me a wall that is 6 meters high. Now, the reason that I'm using these levels and work planes is that if someone came back and went, actually, we've gone back to site and remeasured and we got something really wrong, the level is actually 4 meters. All you have to do is right click on the level, choose properties, and then we can say actually the top altitude is 4 meters, and then everything associated with that level will move automatically. So if you've got a huge floor of steelwork, you don't have to move everything up, you don't have to stretch everything up, the system will do it for you. And if we want to put it back, we'll just put it back to 3 meters. The same with the top, all of these items are locked to the level. Now if you want to remove something from a work plane, we could go in and we could choose detach elements, and we could say, right, well, we actually want to detach this wall, and then it says select your geometry point. So what points are we detaching? So that's the start and the end of the wall. Those items are no longer attached to the second level. So if we change properties of that and we make that 7.5 meters, you'll see that the columns and the 2 rear walls go, but this wall in here doesn't. So we've done too many undos, we'll just put that back to 3 meters. Okay, I'm going to model some internal walls. Now the internal walls, I do actually want them to sit underneath the slab. But if I come in here and activate the work plane, so I go from ground to first, my wall at the moment, if I go from just a nearest point, we'll have a little wall in there, to the perpendicular point, that wall will lock between the levels, but you'll see now that it's passing through our slab and giving us a clash. So again, I'm just going to detach this element, because then what I can do is I can drag that. I know I've got 200mm slab in there, so I can just drag, turn the ortho on, just rotate my UCS so it's dragging in the X direction, and we'll just drag that down 200 just to remove that clash, because we're modeling the existing environment. We don't want to model in clashes. So we'll just go back to realistic there. Wrong one. Realistic. So that's how we would model the concrete environment. I'm in shaded, not realistic, that's better. Now what we have done in here, I'm using a Graitec template that we've created, and what we've done is we've loaded some materials into the template, and there is a command that you can say material attach, and you can attach materials to the layers in your model. So what we've done in here for concrete slabs, we have attached the exposed aggregate medium, and for the concrete walls we've chosen flat grey 1. So we have a one for timber beams, you could add one for glass. Alec has done a webinar on creating a custom template file in Advanced Steel. So it is definitely worth watching that, but you can get a slightly better realistic view. You could do the same for your steelwork, your plates, your bolts, your anchors. So that is the basic concrete. For the polygon items, you do just draw out the shape you want. Did you like that? Yeah, go that way. And then you can draw a polygon slab. The way we would model a polygon wall, what we need to do is we need to change the UCS first. The way I explain the UCS working is your X and your Y is your piece of paper and the Z is your pencil. So if we're creating a wall, we obviously need to rotate our UCS about the X-axis once, and then we can use the polygon wall command. And then if we just draw out our shape and hit enter, there's our wall that is a funny shape. So there's a couple of ways you can do that, and we'll just erase that, and we'll set our UCS back to world. So what we're going to move on to now is the cutouts in the concrete elements. So I'm just going to go to the Project Explorer, and we're going to go back to the model views and activate the first floor. We're just going to turn off snaps. Now, to model an opening in anything is the same as you would make a cutout in a beam or a plate. So we're going to use the Features tab on the tool palette, and we're going to do a rectangular contour. I'm going to say start it here, and then we'll go 4 meters in the X, 2 meters in the Y. And there's the cutout in our concrete slab. If I want to do a cutout in the wall, again I need to manipulate my UCS, because in this scenario when we're doing cutouts, the XY is the object and the Z axis is going to be like our flame cutter or our diamond saw for cutting out holes in the concrete. So what I'm going to do is I'm going to use the UCS at object command, select the concrete wall, and then you'll see that we get lots of lines coming out in different positions on that concrete wall. Now these drive where the X, Y and Z axis go. So you'll see here on the red lines I've got 3 different lengths of line. The longest line that I'm hovering over now is the Z axis. The second longest line is the X axis, and then the shortest line is the Y axis. So I want my X going along the wall, Y going up the wall, Z coming towards me, so we'll choose this one here. That puts the UCS on the axis. And now we can do a view on UCS, and that will take us straight onto the wall. And then we can model a cutout again. I'm going to use the rectangular contour 2 points, choose the wall, choose the nearest point, and we're going to do 1 meter in the X, 2.1 in the Y, and then you can see there's my cutout. What we're going to do, we're just going to model in a quick staircase. Just set that to world and deactivate the level. I then want a line, I didn't quite find it, we'll go to a wireframe. I want a line from the midpoint like that. So we'll just do a line from the nearest, and the line is going to be 500 long, 3 meters in the Y, and then 4.6 in the Z. So that is the construction line for my staircase. So we'll just use the staircase macro. I'm not going to do anything to the stair, I'm just going to put a staircase in. That is fine. We'll choose the endpoint at the bottom, the endpoint at the top, and we want that in the middle. And that will do for the staircase, but you can now see that we've got the opening. We could move the staircase to butt up against a slab. We could model any supporting steelwork underneath the opening. We could model any, if we needed an end plate with anchors, we could model an end plate connection. So that is my existing environment. So what we're going to do now is put some cameras in. We're going to look at GA drawings and the output that we can get with the second part of this webinar. So we're just going to put a couple of cameras in here. So what we're going to do, we're just going to do an elevation on the frame. So we'll just put a camera in at 0, 0, 0, and we'll just call this elevation on new steel, and we will choose an elevation style. We'll do hot roll side all. We'll set the scale to 1 to 25, and we'll lock ourselves to giving us just a slice through that steel. Now what I want to do is I want to copy that to be positioned on the staircase. So I'm just going to use the normal copy command and copy the camera from 0, 0, 0, and I want it to be the midpoint of that step but in line with the staircase. So what I can use is, if I go back to the UCS tab, we have these little buttons here called the X, Y and the Z filters. So what I want to do is, I don't want to move it in the X or Y axis, I just want to pick a point in the Z. So if I choose .Z, in your command line that will say XY of 0 need Z. So now I could do the midpoint of this tread here, and it will still put the camera in the same XY plane as this camera. So it's a very useful little tool, that .x, .y. We'll just change this to pick up the whole staircase. And this is going to be section on staircase. And then we just want a 3D view, so we'll just position ourselves there. Go to our view on UCS, just quickly put in a camera down here, maybe if we turn snaps on. Overall 3D. And we'll do 3D view all assembly labels, I think. Again, we'll set that at 1 to 25. Okay, so we'll just save that and then we'll run the drawings. We'll just pick a process, all cameras A1. So those are my cameras run, so we'll have a look in the document manager. So we'll just open all of these straight up. So you'll see on the 3D view, for example, it is labeling the existing steel with the mark number. Now that is a default that I have changed in my management tool, so we'll just have a look in there. think if we use the filter for existing, in drawing general, there is numbering. There is a default in here, and not, if I can find it. So add labels for objects which are not used for numbering. So although it's existing steel, I still might want to put the section size and put EX in front of it for existing. So I've turned that management default on. So there's my 3D view. You can see the openings, you can see the staircase. Now they did change the way that gratings show. They do show as hidden. In a minute I'm going to change that. There's my elevation on the staircase, and there's my elevation on the new steel. So again, that's got the minus number because the label just says label any steel, and the mark number is minus 1000. So we probably would want to change that in there to existing. So we could do that ourselves. So we're going to look at now manipulating how the existing steel is shown on the drawings, and then I'm also going to show you what can be done with some drawing customization. So at the moment the existing steel will just print exactly as any other steel. So there's two ways of going about manipulating how this existing steel is shown on the drawings. One is with the layers from the model, and the second option is by creating some new drawing styles. So we're going to start with manipulating the way the layers behave and print, and again there is a management default that if we look at drawing presentation and colors, these are all the colors that the system uses, but there is a default at the very bottom that says use color by layer in arrangement drawings for visible lines. So out of the box that will be unticked, so all of your visible lines go to color 143. When you have it ticked, whatever color and whatever layer you use in the model, so my existing steel for example is color 65, because I've got that default ticked, the existing steel will come through with the layer from the model. Now if we get it to come through with a layer from the model, we can manipulate how those colors are plotted. So to do that we need to go into the page setup manager. You don't need to do this on every sheet, we only need to do this once, and the only thing I will warn you of is if you do this once it applies to every drawing. So if you have something else on color 65, the same thing will happen for both items. We're going to modify the advanced steel CTB file, so that is the plot style. So that is effectively when what the CTB file tells the system is when you find this particular color, this is how you plot it. So if you guys are wondering why your holes are plotting as solid red when you're plotting to PDF, that's because the holes are coming through as color 1, and the system is saying color 1 actually plot to red. If we look at the others, it'll say plot to black, use the object line weight, use the object line type. So this is an override. So what I can do is, we know color 65 is the color of my existing steel. So I'm just going to go in here and choose a different color. We'll choose 207, and what I'm going to say is I'm going to say use a dashed line and print it to 0.05. So you won't see any difference in the actual advanced steel DWG, but when we plot these, and we'll plot all of them, the plotted output will be different because it's using the values from the CTB file. So we'll do add to batch plot. I'll print these to PDF and I'll make them a one file. So we'll do a multi-sheet file, and we'll just set those to print. And when that's finished, we'll just open that up. So we'll have a look at the existing environment folder. I've got my existing environment PDF because a multi-sheet file plots to the same name as the main file. We'll start with the 3D view. So you can see in here, oh, come on, those are now plotted to the 207. You can see the line is thinner than the walls and it's a dash line. So that's one method of controlling how those items plot. The only thing with that is that's done it for the outer lines. The hidden line is the same for every object in the system. So if you're showing hidden lines of existing steel, they will show thicker than the outer lines. The other method is to use different drawing styles. So I don't have enough time today to go through how to set up all of the drawing styles, but I'm just going to show you what could be achieved with some fairly small tweaks to the drawing styles. Actually, I've not done a huge amount. So I've got an RM 3D view, all assembly labels, and I've got one for sections as well. If I can find it. So an elevation one. Now what I've done in here is I've added a new hatch in for the concrete elements. So if it finds a concrete element and it's cutting through it like it is on the stair section, it will hatch it for me. So that is RM elevation. So we'll just run all cameras A1 again. And what we tend to say for people when we're looking at drawing styles and drawing style customization is we'll never probably achieve 100% of what you want on every drawing, because every project can change, but the repeatable tasks that you are doing, that you're constantly having to change, if there's dimensions that you're constantly changing, labels that you're constantly changing, we can probably achieve all of those automatically. So if we look at 4, 5 and 6, if we look at the 3D view, it's still pulling through the layers, but all I've done in here is I've created a new labeling strategy that says if you find a model roll existing steel, which these are, then put EX and then the section size, so don't put the mark number in. So on the 3D view, that's all I've done. I have also changed the system so that whatever you type in this box here, so overall 3D, that's what shows in the title, nothing else. And then I've put the scale in there automatically. So if you change the scale of this view, that token will update automatically. The section through the existing steel, again, I've used that existing label to say, right, dimension these as existing. I've also added in a couple of extra dimensions that says if you find a concrete slab, then dimension the thickness of the slab, but also then give me the level information and also the height between the levels. Now, because we've modeled with levels, the system automatically, because we created the levels at the beginning of this webinar, the system automatically will add the level markers for things that it finds. That does only work, well, we'll come back to that in a second. We'll then have a look at the section through. Now the section on the staircase, because it's sectioning through and it's not looking end on the slab or the walls, I can add a hatch in. So I've added a hatch. So I've said to the system, if you find concrete hatch, sorry, if you find a concrete wall, add this hatch. If you find a concrete slab, add that hatch. Now I've set the color to be the red. If you wanted it to be a faint color or that 207, then obviously we could set that. We could set that in the CTB file as well to print to a faint line. I've just done red so it stands out. Now you'll notice in here I don't have any level markers like I do on this elevation here. Now that is because, just set my UCS back to world and turn everything on. We'll just get rid of that wall. When we create the levels within the Project Explorer, what the system does is it creates these little model view boxes. Now, because the camera is slicing through the model view box, it will pick up the level. You see, with this camera here, it's not actually touching any of these model view boxes, so therefore it's not going to give me the level markers. If I put in a quick level marker, so I can just add another one in. Now this does come up as a question, is people say, well, we never model at 0, 0, 0, our site level might be 36 meters. Well, in the level marker we can go to the global option and we can type in 36 meters in millimeters. Now, because I've added that marker to the staircase and I've added in a particular level, the drawing style will now update to show the level marker, but it will now pull through that 36 meters. But what this one does is it's only puts the level marker in where I put it in the model. So the other option we could do is we could just stretch those model view boxes and then they will get picked up automatically. But if I update these view now, it will take our 6 meters, add the 36 onto it, and now that's our level at 42 meters. So that's what we can do with drawing customization. The last little bit we're going to look at for modeling the existing environment is working with an engineer's layout that we've been given. So we'll actually just close this down. We'll just start a new project. So I have an architect's layout that I've been given. Now, I wouldn't ever work in the actual architect's DWG that you've been given because you won't have all your advanced steel layers. So I would just copy the items that you need, start a new advanced steel template file, and then paste those items in. We'll go to a wireframe so it's a little bit easier to see. Because what we can do with this layout is we can, assuming all the steels are on one layer, we can do select similar, and that will pick up all of the lines on the same layer, so that's all of my steel. We then, in advanced steel, have a command that says beam from line. Do I want to delete the lines? I'll say yes. Now we would have to go through and set the section size, but that is all of the beams created from my architect's model. Then what we could do is we could use the connection vault, use a single-sided end plate, put that connection on, call that connection 1 if I can type. And then if I propagate that, that will look for everything in the model. So you can see in here, that's now put, okay, it's missed one there, and it's missed one there. That is probably because the system lines aren't touching. But what we could do is we could just joint copy that ourselves and put them in the group. Okay, we would have to tidy some other things up. These beams are obviously bearing on walls. So while we're looking at walls, if we turn the endpoint on, I would still be tempted to actually model the walls in. I'll explain. We'll just put a couple in, but if you've been given, we could just isolate the wall. We'll just put those in. We'll make them 100 wide. We'll position them there, so they're a bit thicker. They 150. 140 blockwork then. So now we've got our blockwork in, we just need to change the positioning of that one. And then I'll obviously move those down 3 meters, or we would move the steel up. I'm just giving you an example of what could be done. Now, if we want to run a say we didn't model the internal walls, but you still want to see them on a drawing to give your drawing a bit of context. If we open our management tools again, and in the filter we type CAD, there is a default that says allow detailing of CAD entities inside the camera drawing. So if I tick that and we load the defaults in, we'll save this as Architect's example. If I put a camera in, floor plan, and we choose, I don't know, a floor plan style, so floor plan hot rolled all, and I've already got some cameras in this template file, so I'm now going to have a few on top of each other. So it's not that one, it's probably not that one, I should have done this beforehand, it'll be that one I think. Floor plan, we'll just run that one camera. Drawing processes, cameras selected A1 this time. That should now show the architect's layout, but with our steel. Okay, we have his labels in, so I should have taken those out. So, but what we can do, we can open that. Now this is just a block now within the drawing, so I could select that and do select similar, take those out. I could select all of the lines and go to the properties, and I could change color. Again, I like the 207 because it's what I used to use, and we used to make it faint, so that we would make the outline faint, but then you can still see in here our steelwork with that architect's layout. And if we change the scale, that block will scale with it. So again, we move this and everything moves at the same time for us. Now the reason I modelled the walls in there, so if I model the walls, maybe what we should have done is taken out the endpoints, the lines of the walls that we'd modelled, because you don't want to dimension to the endpoints in here, because when you update the drawing, that's a point that the system isn't going to be able to track back to the model, and therefore it's probably going to remove the dimension from the end of the beam to the concrete wall. But that is just something that can be done with an architect's layout. And that takes us to the end of today's webinar. We at Graitec in the UK are here to help you with advanced steel. We have written out what we call a roadmap. So that is broken down into what we call the 5 steps to success with advanced steel. So step 1 is when you do your basic training. Step 2 is what we call like a technology implementation or an implementation day. So that would be where someone like myself or Alec would come to you after the training, and we would spend a day with you getting all of your systems set up, changing the logos, setting up all your prototypes, setting everything so that you have an out-of-the-box advanced steel that suits you and your workshop. Then step 3 is the documentation, training and customization. So where we looked at the drawing style customization, we do run a 2-day training course for that, or we do offer now, especially in the COVID situation, what we call workshop days, where normally again you guys would write out a list of everything that you're manually doing, manually editing. Myself and Alec would come and spend the day with you, and we would just try and reduce that list down to nothing so that you guys aren't manually adding things. We can't achieve everything, but on the repetitive tasks we can confidently say that most of the repetitive tasks that you are doing, like adding the scale to a drawing view, deleting things from the title, putting hatches in for certain elements, we can do that and get the system to do it automatically. So you can either learn how to do it yourself and then just do it when you need, or we can do a workshop day, and now we do those as an online workshop day. If you do have any questions, my contact information is on the screen here. It is shown in the handout. Please don't hesitate to get in contact with us. We are here to help you. And thank you very much for attending today's webinar.